It's time for This Week in Science and Education, the internet show that talks about all things health research and science related, new discoveries, new cures. How do we take this information and how do we make it relevant for the teachers and students in today's classroom? We're going to find out next. Stay tuned for This Week in Science and Education. This Week in Science and Education is brought to you by Sheridan Institute of Technology and Advanced Learning. At Sheridan, students shine brighter. Visit their website at SheridanShineBrighter.com. Hey everybody, it's time for This Week in Science and Education. This is your host, Kevin Cougler. We're recording today episode 36 on Tuesday, April 19th. Our special guest today is Dr. Richard Petrone from Wilfrid Laurier University. But before we get to our special guest, I do want to welcome my regular co-host, Mr. Colin Jagoe from the Kawartha Pine Ridge District School Board. What's happening, Colin?
Not much. It's a lovely spring day here. Finally, the sun is out, and it feels like it might start to warm up soon. So it's a good day to be here.
Well, that'd be nice. We had snow here yesterday. Did you guys get that?
I know. We got a few flakes. We didn't get as much as you guys got down that end of the province, but it was cold and miserable. So it's nice to be sunny and warm today.
Colin, I don't know if you've noticed, but Thomas is looking a little different today from the way he normally looks.
I did, and he's also looking like he's not in Sudbury either.
This is Dr. Greg Kelly. Greg is from the University of Western Ontario here, and he's, I don't know if it's foolishly, but we're very grateful that he volunteered for Thomas today, and we're very glad to have you here. Thanks, Greg, for coming on the show.
Thank you very much.
Give us a little idea of what it is that you do here at UWO.
I'm a professor in the Department of Biology. I've been here since '95. My work is mainly on looking at the cell signaling events that pattern early vertebrate embryos. I'm a molecular geneticist, so I study the genes. I look to see how they interact, and then I perturb them and see what's missing in the developing embryo.
Do you ever do any work with fruit flies?
My neighbor does fruit fly work, so they invade my office, and that's into my work with fruit flies.
See, there's a tie-in because Dr. Merritt, Thomas does fruit fly research, so there you go. He's kind of close to us.
Close enough.
That's right.
Anyways, so yeah, thanks again, Greg, for coming on the show. I appreciate your help today.
Thank you.
You're going to help us interview our guest, and this is Dr. Richard Petrone from the Wilfrid Laurier University. I'll just do a quick introduction, Dr. Petrone, then I'll ask you to carry on and talk a little bit about your research. So Dr. Petrone is from Wilfrid Laurier, as I mentioned. He received his PhD from the University of Waterloo in the year 2002. He accepted his position at Wilfrid Laurier University in the same year, and in 2004 he was appointed the director of the Cold Regions Research Center. Dr. Petrone, welcome to the show, and thanks for taking the time to join us today.
Great, thanks for having me.
So Dr. Petrone, tell us a little bit about what the Cold Regions Research Center is all about and your role as the director there.
The center has been around for about 30 years now at the university, and it was established to bring together anybody doing cold climate, cold regions related research, everything from anthropology, archaeological type of research to history and the environmental sciences. And sort of the focus of the center has varied over that 30 years. It's gone from, kind of a good mix of different disciplines with cold region interest, which I should say is not only north. We look at, over the years we've had people working at both poles, but also mountain types of environments, cold, lots of snow as well. Right now the emphasis of the center is more on northern resources, resource management, environmental science, those types of things. And so the membership, the current faculty that make up our research center now are people with interests in those areas. And it's my role as director is to try and facilitate interactions amongst all these people. Especially a lot of our emphasis is on the students, the undergraduate and graduate students that work on some of these projects. We try and create an environment at the center where they can interact easily and they get exposure. It's really good because not only in their narrow research focus, but they get to interact with students doing other types of research with that overriding or northern or cold regions theme. And then the other aspect of the job is to promote what we do to the broader community. A lot of people are surprised that there's a research center that focuses on northern science and whatnot in southern Ontario. And so we do a lot of PR work and host public events to raise awareness of northern issues that are also issues that we, as Canadians, all need to be aware of and take interest in.
And I imagine at this time in our history, with climate change being front of a lot of what we discuss, your job is a particularly interesting one, I would imagine.
Yeah, and because a lot of where we do a lot of this work is in an area that's expected to respond first and probably most dramatically to any sort of climate change. So the research that we do has that climate change element, and it's also important from the resource management point of view, where a lot of the resources that, from forestry to oil and gas and even probably more importantly water itself in that area are all very susceptible to any sort of climate variability. So and the thing that this time of year, just past every winter, things sort of heat up where people, if it's a good winter, you've used your snowblower too much, that, well, climate change can't be happening. So there's always that aspect too, where we have to try and convince people that no, it's still it's still changing.
We certainly felt it at our place this year. There's no question. You're the associate professor. You're also the director of the center, but I understand you're still very actively involved in research. Maybe talk a little bit about your specific interests.
I guess for about 8 or 9 years now, I've focused most of my work in the northern Alberta, southern Northwest Territories. I became interested in that area for a few reasons. I've picked sort of you almost imagine a line of research sites running from, just north of Edmonton up to about Yellowknife. And if we were to walk that line, we're really walking, right across the Boreal to the subarctic transition zone. So when we're at the south, it's dominated by aspen forests and wetlands, and as we get further north, there's less trees, more wetlands, and a lot of ice, permafrost, that sort of thing. So it's an area that we're going to see a lot of change in response to climate change. We expect tree line's going to move in both directions in different ways, but permafrost is going to melt out, so that's going to have profound impacts on not only what the landscape will look like to us in the future, but on the resources. And my interest specifically is the water aspect of those natural resources. There's a large amount of the world's fresh water supply is actually locked up in our boreal and Arctic zones and wetlands and permafrost and so on. So we have a responsibility to protect that resource, not only for the people who live immediately in that area, but I think as Canadians in general. So looking at how that area and how that water supply is going to respond to any climate variability. And the second thing that I found really interesting is you have this very climatically active area that's also a hotbed of the resource industry. We have, towards the southern end, forestry is very extensive, and as we start to go up a little bit, we get conventional oil and gas exploration, and then, of course, the oil sands. And as you get more into the Northwest Territories, there's more pipeline development and those types of things going on. So it's not only looking at what are the effects of maybe a warming climate going to have on that landscape, but how does that landscape deal with all that disturbance within that broader climate picture. So a lot of my research is looking at not only natural systems, but in the last 3 or 4 years, I've been more and more active in reclamation research as well. So working with the oil sands industry and some forestry partners as well, and looking at how can we reclaim the landscapes after the resource exploitation. So in a nutshell.
Sure, yeah. There's probably some students out there that are wondering, you say you conduct research in the north. How do you actually do that? Do you get in a plane and fly up there several times a year? Give us an idea of the actual, how does this all take place?
Yeah, well, given that, as I said, my interest is more in the water aspect, I like to get up there as soon as the water starts to move. So we'd like to get up in the field and start to, look at where water is being stored in the landscape, where is it going, and we like to start to do that as soon as the snow starts to melt and the ice starts to melt out. So usually around this time of year, myself and students who work with me will head out to the field and start to install our equipment, and that's everything from putting wells in the ground to look at where the water is in the soil, to putting weather stations up to look at, things like evaporation, which is water that's going from the surface back up to the atmosphere, and we measure what's coming down as well, and precipitation. I guess you can sort of imagine we try and go out and treat these areas as like a big bucket, and we want to look at how much water is coming into the bucket, how much stays in the bucket, and what are the holes in that bucket. So we look at rainfall, snowfall is coming in, we look at evaporation, groundwater, that sort of thing is going out. And that area as well is actually a fairly dry climate. We imagine it as being, cold and lots of snow, but actually if we look at how much rainfall and snowfall it receives on an annual basis, it receives much less than it loses back to the atmosphere. So it's what we would call a subhumid climate. And it's interesting because it's dominated by wetlands. So how do we have wetlands in a dry climate? So that's one of the reasons why the water and getting out there and looking at where the water is moving in the landscape, what parts of the landscape store water, is it in the ponds, lakes, wetlands, that sort of thing. So, sorry, I forgot the question. I guess what is a typical field season, I guess is what you were getting at for. So we get up there now, start to install, and I typically leave relatively quickly, but I have grad students who, depending on the project and what their interests are, might stay 3 or 4 months at a time, or we'll do several trips. But
Hey, Colin, doesn't that sound like a dream job, for a grad student traveling up to the north, maybe doing some canoeing in some of the lakes,
if you
just
like,
being surrounded by that
it's the spring up there.
Yeah.
It's what that environment's like. And listen, I did have a couple of questions. I'm just thinking about the practical aspects. Like you mentioned about installing various weather stations and monitoring all this moisture content and things like that. Talk to us about sort of some of the specifics, right? Like how many weather stations, how far apart are they? I mean, you're talking about a huge geographic area.
Yep.
How do you get a good sense of that geographic area with the measurements that you do and sort of the stations that you set up? Like, is there a ton of them, or is there sort of strategically placed? How does that sort of work?
So a little bit of both. We try and pick strategic areas. So, at one particular time, we might be focusing more on the wetlands and, what's the wetland role in terms of water storage and that sort of thing. Or we might be looking at particular disturbance features, like maybe there's a road effect on a wetland that we want to investigate, or those types of things. So we might focus in on specific areas, but within each of those areas we would have, say, probably one big weather station set up that would basically see the whole area that we're interested in. And then within that we would have a lot of smaller scales sort of surface measurements. So we might have anywhere from a half a dozen to several dozen wells in the ground to look at how water is flowing through it and that sort of thing.
So do you dig the wells seasonally? Do they change every year?
No, we typically put them in and they're in for the duration of a project. So
I want to give Greg a chance to jump in here. If Greg, you have any questions for Dr.
Sure.
Patron?
Richard, I've got a couple of questions, one from a scientist's point of view and another more from a let's say the Joe Public point of view. And the first one, your research center, is it a virtual center or is there a building associated with it? And for instance, where does the funding come from to support all the fellows? And sort of part two to that question is, it seems like we're in the midst of another election, and I've yet to even hear the candidates talking about these very important environmental issues.
Increased funding for science.
Yeah, increased funding. So that's kind of my two-part, scientific point of view, and then I'll come back to the from a layperson's question.
Okay. guess the first part of your question, we are an actual physical center. We do have not a whole building, but a portion of a floor, I guess. And so we have in that a library where we keep our collection of everything from, journals pertaining specifically to northern or cold regions types of projects, theses that students have done over the years, as well as maps and other sort of, hard copy archive data. But the biggest component of that area is, again, the focus more on the students. So we have a fairly large student office space or room, and that's where we try and keep all the graduate students and undergraduate students who are doing, projects as part of their undergrad theses and that working together. The money to pay for it comes largely from the university. We have an annual operating budget, and the other portion of our income comes from research funding. So projects that faculty in the center are involved with, money comes through the center, and then there's also overhead charged on industry grants and certain types of research contracts that also get fed back into the operating of the center. So we're not huge, but for our size, we're fairly productive in terms of the number of people involved in that. The other aspect in terms of funding and the politics, I guess, behind not only this kind of research, but everything, we're all feeling the pinch in terms of funding structure in Canada. I think now, at least in the earth and environmental sciences, the national body, NSERC, the Natural Science and Engineering Research Council, has changed their model for a lot of their types of programs in the last few years, and every year they come up with different strategic areas. And the challenge we're finding now from a hydrologist or environmental scientist point of view is that for some reason water didn't really come out in the last round of strategic areas as being water as a resource on its own. It has been in the past, so we're having to find ways of doing important water research while tying it in with other aspects that have been defined as important by the government. And of course, it's been a few years since we've really been able to say we're doing climate change research. We kind of sneak climate change research in under the umbrella of doing other types of environmental work. But it's been a few years since the Canadian Foundation for Climate and Atmospheric Sciences was dissolved, and they were a great funding agency run by the federal government in terms of doing pure, climate and atmospheric science related research, and that no longer exists. And so maybe with the change in government, we'll see that climate again becomes a strategic area or an area of importance. But it's been challenging. One thing, we've entered into a partnership with the government of the Northwest Territories a couple of years ago, and we're working with them now from the science end of things to help implement their water strategy. So it's while we're kind of getting ignored by the feds, it's been nice to see a territorial government taking a very active and progressive stance on managing what they see as their most important resource in the territory. So we've gotten funding with them, from them, as well as started an academic partnership. So Laurier actually has, or we're working on it now, we'll have an office in Yellowknife for a liaison position and that sort of thing. We want to make sure that the science that's being done now in the territories, especially around water and resource management, finds its way back to the people in the territories that need it. So the people in government who are doing the policy and the management get the science that they need to be effective, and also that the scientists know what's important on the ground as well. So kind of, I guess, outside the scope of what your question was, but it kind of ties into the the funding and the politics of it.
What was your layman's question?
My layman's question is, we're currently interviewing people for a position very much like that would fit in here.
He already has a job.
Oh, we're not trying to poach you. And I never got a chance to ask the candidates these questions, but when the scientists talk, they talk about climate change, and yet when the public talks, they talk about global warming.
Yeah.
Can you comment sort of what is the is it hair splitting?
Yeah, I don't know that the problem what I always try and watch when I talk about it, and I tend to lean more towards using climate change, is because of, I mentioned a little while ago that, in the middle of winter, typically a lot of the skeptics and the people who don't necessarily believe that climate change is happening come out and say, well, it's a cold winter. It's cold as it's been in the last 5 years, and we've got more snow than we have since whatever. Global warming can't be happening. So I think when we say global warming, everybody assumes that the planet's mean temperature is going to continue to go up every year, and there's going to be no little blips in that increase, and it's only going to go up and keep going up. Whereas we've learned over the last couple of decades in climate research, and the models have started to show that there is a lot of variability. And if we look at the long-term trends, things will keep going up. But within that long-term trends, there's going to be years that will be colder than the previous few. And there's going to be years that are a lot hotter than, the increase in temperature will look a lot larger in some years than others. So I think from my perspective, I tend to see climate change as being a safer term to use, where we can, as we continue to talk about it, say, well, it is warming. I think everybody understands that. But climate change kind of implies that the shorter-term variability that everybody sees on a daily basis, and trying to make that connection to the public that that variability is still part of that overall warming.
What are we saying in schools, Colin?
About that particular topic? I mean,
Well,
it's
are
climate
we...
change. Yeah. No, the way Richard just described it there is exactly how teachers would describe it. That's exactly how the curriculum here in Ontario describes it. It's climate change, and it talks about how, yes, the overall average temperature is going up, but with that comes more heat, and with more heat comes more heat transfer, which means more variability, which means higher highs and lower lows and drier dries and wetter wets and all of that. So you get sort of wild weather, and that all, a really cold winter could be a sign of quote-unquote warming, which is sort of a bit of an oxymoron, but it's the reality of it. And so that's embedded right in what we're teaching right now, trying to get that understanding right from, say, grade 9 and 10 right on up.
That's great.
Dr. Patron, will you take a question? We had some questions come in from a couple students over the last week from across Canada, and kind of interesting. Would you like to take one from a grade 8 student?
Sure.
Okay, well, this is from Reese. He's a grade 8 student in Alberta, so, right, well within your range of research there. Reese wants to know, what will the impact be on animals in our cold regions as our climate continues to change in years to come? I'm assuming he means, of course, in the northern part of Alberta there. What would your answer be for Reese?
I think, not only in the north, but we can look at sort of any climate zone or biome, and as the climate changes, the animals are going to, and the species that live there, are going to have to adapt to that change. But as I think we talked about briefly earlier, that the north is seeing the change first, and it's seeing it the quickest, and some of the most drastic changes are going to be in the north. And we see, there was not long ago an article out of Alaska where somebody with the Wildlife Service tracked a polar bear mother and her cub, swam something like 560 kilometers to get between ice floes. And the baby died, but the mother made it. So we're starting to see, things like polar bears already having to deal with changing ice patterns and, changes in the duration of how long is our parts of the ocean frozen. They can't get on the ice. They can't eat. And we're also seeing it, on the land itself. And right now in the north, there's a big crisis with caribou. They don't know where 95% of Northwest Territories caribou's gone in the last year or two. And there's a moratorium on all hunting, and they think it's overhunting, but it could also be tied to climate change. If we think about it, caribou like to eat lichen, and lichen like to grow on drier, peaty areas. And those drier, peaty areas in the north are usually where there's permafrost underneath. And we know that permafrost is melting already in large areas of the territory, especially towards the south, where it's kind of patchy as it is. So as that permafrost disappears, those peaty areas start to get wetter. They sink, they get wetter. The lichen don't like that, so they die off. So there could be less food around for the caribou to feed on. So things like that, we get direct effects where we see with the polar bears, where they don't have, the ice they need to live on. but there might be trickle-down effects like we see with species like caribou and that. So I guess to answer your question quickly, too late, is I think you're going to see changes in how everything survives up there. And some, there might be bigger losers than others. Some we might see, unfortunately, disappear completely, whereas others, maybe where they live and their range of existence is going to have to change.
Thank you for that answer. Let's take another question while we've got some time, and then we'll do a short break and come back and talk some more with Dr. Patron. This question is from, and thank you, Reese, from Alberta for that question. Appreciate that. This is from Natalie. Natalie is a grade 11 student, and she's from New Brunswick, Mr. Jagoe. How about that? Natalie's question is, I've heard the Alberta oil sands are not an unlimited resource. What will the impact be on the native environment as the oil sands are depleted, if any? And you kind of touched on this, I think, at the beginning of the show, but maybe if you wouldn't mind addressing that question for Natalie.
Yeah, that's a great question. Yeah, it's definitely a finite resource, and so they're looking to get, to develop as much of it as they can in the next, I think the timeline on most projects are 50 years or so. But the problem with it is, unlike conventional oil where we can drill holes to get at it, with, relatively speaking, a lot less impact to the natural environment. The oil sands, it's close enough to the surface that we dig it up. Not we, I have nothing to do with the extraction, but the industry digs it up. And doing that, they create huge open pit mines. So part of them being allowed to extract that oil is they have to return the landscape back to a functioning natural ecosystem. So if it was a wetland before, they are supposed to put it back to a functioning wetland ecosystem when they're done. Now the problem is wetlands can take hundreds, if not thousands, of years to develop. So, for instance, if we have a peat bog that maybe has 10 meters of peat, peat accumulates at about 1 to 2 millimeters per year. So a bog that maybe we've extracted oil from in that part of Alberta could be 10,000 years old. So how do we know when we construct a wetland back on that landscape that it's actually going to become a bog again? So we try to come up with indicators to, does it look like it's on its way to becoming a functional wetland system? So I guess that's the idea, is they have to try and put something natural back, but its chances of it being native are probably pretty slim, or at least I don't think we'll be able to evaluate in our lifetime whether or not it's achieved that goal. And the other issue is these features, things like wetlands are so old, they've developed under really different climate conditions as well than what we have now. Because even ignoring man-made climate change, climate varies significantly over thousands of years. So do we even have the climate to construct some of these systems? We think we have the the tools and the know-how now to at least get something back that's going to function in a pretty natural state. But whether or not it'll be, as I said, what was there initially or what the native conditions were, it's tough to say.
Colin, quick comment before we break, if I read.
Yeah, it just sort of strikes me as sort of any type of natural resource extraction, and what struck me, you're talking about that, thinking about lichen in sort of this subalpine environment or subarctic environment, relating it to like old growth forest, right? We cut down these massive old growth trees, and then we plant new little tiny ones and say that we've regenerated the forest, but it's going to take 400 years for it to get to the way the old growth forest was before we cut it. So it strikes me as a very similar sort of conundrum on resource extraction and land reclamation. So it's quite interesting to draw that parallel.
Yep.
Okay, we'll take a quick break now. I do want to mention our good friends over at Mueller Systems in Woodstock, Ontario. If you have some data out there and you need to get it protected, we encourage you to have a look at Mueller Systems and their backup solution. That website is Mueller Data, that's MULLERDATA.com/VROC, VROC. Check it out. You can download, install, and configure the backup software free for 90 days. I can't think of a better way to make sure that your data is adequately protected. If you just have a little stick or a CD-ROM or something, that's likely not going to be the best way to back up your data. And even external hard drives can fail if you get some type of an electrical surge in your house or at your office. You need something across the internet. Go to the cloud. So that's what the fine folks at Mueller Systems provide for you. MuellerData.com/VRock. You can go to MuellerData.com, but we really ask you to put in the /VRock so then we can get some credit for it, and we really appreciate you doing that. Thanks again to Mueller Systems for being a strong supporter of This Week in Science and Education. Back to the show. We're having an interesting discussion with Dr. Patron from Wilfrid Laurier University. Greg, chance for you to jump in, if you will.
Yeah.
Did you prepare that presentation you said you were going to?
I have it right with me here. Backed up and everything. Richard, I have a question. You brought up the word trying to reclamation, and I'm wondering, I'm sure it's the same where you are, but we're watching the gas pumps go up, constantly on a weekly basis. They're making a lot of money. How much money are these big oil companies putting back? And if they are putting back in for independent research studies, do you think there's any type of, or is there any type of review that one has to follow their guidelines before a paper can be submitted?
Yeah, and we get that a lot. It's a common question people ask about any, industrially funded research with the oil sands in particular. They do put a lot into research and development. There's a couple of organizations that are sort of a conglomerate of all the big players in the oil sands. One is the Cumulative Environmental Managers Association, and the other is the Canadian Oil Sands Network for Research and Development. And every company has to pay in so much of their, I think it's based on their sales or royalties or something like that, but everybody has to put into a pot that funds research in a variety of areas. Obviously, there's in the R&D end, there's the extraction and the operations end that gets a lot, but they do put a lot of money into research and development related to reclamation. How do we construct wetlands and that sort of thing. My experience on the other aspect of your question has been so far so good. We haven't had too many issues in terms of intellectual property and publishing. The only thing they tend to, even though they work together in these groups, they're very possessive of their own site data or site information. They don't so much care if I publish, evapotranspiration from, a particular mine site that belongs to one company or water table levels. What they're more worried about is me publishing pictures of that site and, where is that water table being measured and site names and locations and that sort of thing. They try and, so whenever we sort of pass stuff by them before it gets published or presented, it's usually more that sort of stuff that they look out for, that we're not giving away, technical details of their operations or locations. But in terms of the science, I haven't, at least so far, not had any issues with it.
Colin, any quick comments for Dr. Patron?
No, that's really interesting, actually. I've often wondered that about how, because I know that there's a lot of funding through the companies on that, and it was always interesting how we dealt with the research. If I could take a little detour and ask a different kind of question, we talked earlier about the election and the fact that there's very little environmental issues being put forth this time around, which is a bit of a shame. But one of the things that I did see come across just this week was the Progressive Conservatives put forth on their platform, if they get elected, they're going to complete the Dempster Highway to be able to drive to the Arctic Ocean. That's sea to sea to sea completion of the highways. Can you maybe talk a bit about sort of that from a development point in the north and what impact a highway going all the way through may have on land and on climate and on the resources up there?
Yeah, and I think there's a lot of interesting stuff around that. Some colleagues in the NWT that are looking at the effects of highways and that type of infrastructure. It's whenever you're dealing with permafrost, it's an engineering challenge, to say the least. That's why people are really concerned with the proposed pipelines and that sort of thing. So even in the normal circumstances, when you have permafrost and seasonal thaw over, a given thickness of the surface, there's always movement of that surface. So if you're running a pipeline on that surface, it's going to be moving. You put a road or anything, there's going to be, frost heaving. We see it on a smaller scale on our own roads, in Ontario too after winter. So there's always those challenges, and I think that's kind of why the Dempster is not complete as it is, and why we rely on winter and ice roads and so on, because it's just there's areas where, especially when you're going through more wetland-dominated areas, it's pretty tough to put anything permanent in that landscape. But people are looking at, in the territories as well, not only what are the effects on the infrastructure itself, but on the landscape around it. And they're starting to see that you put a road through an area, not only are you affecting the permafrost under that road, but you're affecting the water flow and the permafrost on either side of that road. So they're starting to see things like slumping of hill slopes and that around roads. So the road itself and the actual construction and maintenance of the road, I could see it's going to really challenging and in the long term very expensive, unless there's a team of engineers out there somewhere that we don't know about is northern scientists that have this permafrost aspect nailed down. Resource extraction, it could be huge. A lot of the challenges now, especially with conventional oil and gas, is that they're getting into remote areas, and to get into those remote areas, they're airlifting, relying on winter roads, for the most part, winter roads. So it's expensive, and they have a very narrow window of opportunity to actually drill. So they get all their big rigs in, and they've got to drill really fast and get everything out before the road conditions change, or they end up having equipment downtime cost them a lot of money. So I could see having permanent roads in a lot of these areas could potentially really open things up, but it would be a mess.
Colin, give me an education space, for the teachers out there listening. What subject level are we talking about here where these types of issues are coming into play?
You know what? I was sitting here thinking about it. I mean, it covers so many different things. I mean, first of all, just talking about water and how you're talking about water cycling and water movement. I mean, the water cycle is a very basic concept at some of the lower grades, but that carries on right through. So using that as a vehicle to get at all of the other issues is really cool, and you can embed that just about anywhere. I mean, in high school, you're looking at environmental science in grade 10 and grade 9 and ecosystems, but it's all about the human impact, because everything you've talked so far, you're looking at a natural response to something humans are doing and how you're measuring it. So you can draw parallels in so many different areas, right through the curriculum, particularly in Ontario, because we have this focus on what's called STSC, which is focused on science and society, technology, and the environment, right, and how all of these things work together. So when you pick a focus like the research that you do, you can pretty much stick it anywhere. Even something like you talked about building the roads, and how the structure and the form and the function of roads, right, as a physical structure, is impacted by the environmental aspect and the permafrost and the changes. So it's just my mind sitting here pulling all of these different things together actually as we talk about it, because it's very cool. There's so much rich stuff to draw from.
Any comments on that, Dr. Patron?
Yeah, it's interesting to hear that from your end too, to see where some of this material can be introduced. The challenges I have, and I know talking to my colleagues here and at other universities, is that we're usually in geography departments, and we find that most students coming in first year have no idea what we do. I still hear, our liaison office bringing tours of potential students through, and they come through our department and say, well, there's the map library, you can make maps in there. So I think a lot of people come to the university thinking, I make maps.
Right.
Right. So it's good that I think the more we can start to make those connections in high school, like you said, between disciplines, when they start to look at universities and undergraduate calendars, they'll start to see those connections there as well, and better prepare them, I think, for what they're going to get in university, regardless of what department or stream.
Exactly. It's really interesting. It's research, right? And I think very often, and this is why one of the reasons I'm doing this podcast is high school students are not very often exposed to research, whether it's science research or geography research or whatever it happens to be, but it's the methods and mindset of doing research that's really important. So that's really cool to hear you say that.
Yeah.
Maybe we can help you get the word out. If I'm a student out there, where should I go to get some more information about who you are and what you do?
My webpage would be a good start. Also, the Cold Regions Research Center webpage has a good summary of not only what I'm on, other people in the center if they're interested in northern work. But if not, I would. There's a lot of universities, and most universities in Ontario have really good focuses on water research and related to climate change and other aspects. So I think, yeah, the web's a great place to start, assuming we keep our web pages up to date.
And I'm just pulling up a copy right now of the website for the Cold Regions Research Center, which is www.wlu.ca/coldregions. We encourage you to check that out. And of course, as usual, we will have all of this information in our show notes at T-WiSE.vrock.ca. Last question for you, Dr. Petrone, before I give my fantastic co-host here the last kick of the can. But I'm wondering if I'm a student and I'm interested in getting involved. If I'm interested in this as a particular career choice, what kind of subjects should I be studying, and what kind of things could I be doing to help prepare myself so that I come to university as an undergrad a little more informed on this subject?
Yeah, it's in some ways it's a difficult question to answer. It's because we like to have students. Yeah. The breadth and the ability to integrate, like we just talked about, and see the connections between different aspects of these issues is great. But ultimately, we want them to have a good, solid science foundation as well. To do, for example, if you wanted to come and study, have a water focus to your undergrad and go on to graduate work or whatever after that. Looking at water requires, not only how much water, where it goes, but also the quality. So if you're interested more in water quality, you can want to have, your basic chemistry and biology before you come into university. How water moves is all, basic physics. So it's tall demands on students to get done now, I guess, in 4 years. We want you to have the math background and all, be able to integrate, and have all the basic foundations and the core sciences. But at the same time, I guess the interest is probably more important than the raw or the basic background courses, and that's probably what they get more from these broader courses that might integrate and show them, how issues are related and that sort of thing. I think if they come in with the passion and the desire in first year, it's every university has the tools in place to help them plan the path from there. So I think it's great if they're getting exposed to these types of things early on. I heard, grade 9 even is great.
So stay in school and keep taking the sciences. Make sure they're a part of your curriculum, I guess, is the message, Greg?
It sounds like it, yeah.
Any last questions for our guest today?
I have one more question for you, Richard, because you touched on that a lot of your work involves, it's field-based studies.
Yeah.
Is there a lab base where, you have people coming in maybe trying to create simulations or modeling, or is there a computer aspect side that a student could get interested in?
Yeah, and that's a big part is both actually lab-based and modeling studies are important aspects in these fields, because we don't always get what we're looking for in the field in terms of conditions. A lot of times, unless you make a career out of working at the same site on the same question, we're only going to get a narrow window of what the climate might be or the background environmental conditions. So a lot of what we do does involve bringing back samples, for example, from what I do in my research, and oftentimes we'll bring back peat monoliths, because a lot of what I focus on are the wetlands. So we'll bring back big chunks of wetland back and look at freeze-thaw cycles in the lab, and how does the water movement in those blocks of peat change with freezing and thawing, and also we can tie that into the chemistry and greenhouse gases. And modeling is most of us in my part of the field don't use modeling so much in a forecasting or in a predictive way like we would see in the Weather Network, or we see the climate model predictions. We use modeling more to teach us what we don't know about the area that we're studying. So models are a good conceptual guess, basically, at how we think a particular aspect of the environment works. So we put our real-world experience, our field data, into those models, and does it tell us what we expect it to? If not, we look at why. Is the model not correct? If not, what do we need to tell the model from our real-world experiences to make it better? And sometimes we use it to help further direct research in the field and so on. So those are good, because not everybody is into the field aspect too, but they're, I'd say equally weighted in terms of their importance and contributions to that area. Studying stuff in the field, laboratory experiments, as well as modeling.
Dr. Richard Petrone was our special guest today, joining us from Wilfrid Laurier University. Dr. Petrone, thank you so much for coming on the show. It's been a pleasure to have you here today and to share your obvious wealth of information. Thank you so much.
Thank you. My pleasure.
Yeah, thanks very much.
Thanks.
On behalf of Colin Jagoe from the Kawartha District Pine Ridge School Board and Dr. Greg Kelly from University of Western Ontario, this is Kevin Cougler, virtual researcher on call, signing off, saying thanks again for joining us, everybody. See you again same time next week. Take care. Have a safe and happy week.
Thanks.